What if I told you that out of dozens of supplements tested in one of the most rigorous anti-aging experiments ever conducted, resveratrol failed, curcumin failed, vitamin E failed, metformin failed, but 5 surprising substances actually worked? Today, we're breaking down exactly what they are, how they work, and what this means for you. This isn't your typical supplement review. Everything I'm about to share comes from a program called the Intervention Testing Program, or ITP, funded by the National Institute on Aging in the US. Here's what makes it special. The same substances are tested simultaneously in 3 completely independent laboratories across the country, using the same protocol on the same type of normal, unmodified mice. No cherry picking, no lab bias. If a result shows up in all 3 locations, that's not luck. That's called reproducibility, one of the gold standards of science. Over the years, the ITP has tested more than 50 different interventions, most of them 0 effect on lifespan. The 5 I'm about to show you survived to that brutal natural selection. First up, and probably the most talked about molecule in longevity science right now, rapamycin. It extended median lifespan by 9 to 14% in both male and female mice. And here's the kicker, it worked even when given to already elderly animals. That's incredibly rare. Most interventions need to start early to have any effect. How does it work? Rapamycin inhibits a protein complex called mTOR1, essentially the body's growth and build switch. When mTOR is active, the cell is in construction mode. When it's suppressed, the cell shifts into repair and recycling mode, a process called autophagy. Think of it as switching from building new floors onto a skyscraper to actually fixing the foundation. Rapamycin is already used in medicine as an immunosuppressant after organ transplants, but in anti-aging research, the doses being studied are far lower, and early human trials show promising effects on immune function, metabolic markers, and vaccine response. No direct proof it extends human life yet, but it's the closest thing we have to a longevity drug with real mechanistic backing. Next, acarbose. This one's a prescription drug used in type 2 diabetes, and it works by slowing down how fast your gut absorbs carbohydrates. It blocks the enzyme that breaks apart glucose chains in the intestine. The result, blunted blood sugar spikes after meals, lower insulin, lower IGF-1, and, you guessed it, suppressed mTOR1 activity. In ITP testing, male mice lived 10 to 22% longer. Some individuals lived significantly beyond what's typical for their species. The effect in females was weaker, more on why in a moment. No human longevity data yet, but acarbose has decades of safety data in diabetic patients, an interesting sleeper candidate. Third on the list, canagliflozin, an SGLT2 inhibitor. This drug is used for type 2 diabetes, heart failure, and early-stage kidney disease. Here's how it works. Normally, your kidneys filter glucose out of your blood and then reabsorb about 90% of it back. Canagliflozin blocks that reabsorption, so glucose gets excreted in urine instead. The body compensates by lowering blood sugar and burning more energy. Again, insulin drops, IGF-1 drops, mTOR1 activity drops. Male mice in ITP lived 10 to 25% longer, no measurable effect in females. This drug already has impressive clinical data in humans for cardiovascular and kidney protection, but again, no longevity data yet. You've probably noticed a pattern: 3 drugs, strong effects in males, weak or no effect in females. Why? The answer likely comes down to baseline mTOR activity. Males have higher mTOR1 activity. They're running hotter metabolically. They accumulate damage faster. So when you hit the brakes on mTOR, the effect is more dramatic. Females naturally have lower mTOR activity, and their estrogen already provides a layer of metabolic and vascular protection, so the same intervention has less room to make an impact. The takeaway, there is no universal longevity strategy. Sex, age, metabolic profile, they all determine which lever actually matters for you. This one surprises people. 17-alpha estradiol, a form of estrogen, extended male lifespan by 12 to 19% with no effect in females. Before you raise an eyebrow, this is not the estrogen that drives female characteristics. That's 17-beta estradiol. The alpha form has almost no feminizing effect, but it does retain estrogen's protective benefits for blood vessels, bones, and metabolic regulation. Males have almost none of it naturally. Adding it gave them access to a layer of protection they were missing. Females already have estrogen, so topping it up changes nothing. This is one of the strongest sex-specific signals in the entire ITP dataset. And finally, the most humble entry on the list, glycine. Just a simple amino acid, one you can buy at any supplement store. In ITP, it extended median lifespan by a modest 4 to 6%, not dramatic, but reproducible. Glycine is a precursor to glutathione, your body's master antioxidant. It also plays roles in cellular signaling and metabolic regulation. Think of it as a gentle tune-up rather than an engine overhaul. Why does it matter that it made the list? Because it shows that even mild nutritional interventions can move the needle on aging if they're targeting real biological mechanisms. The effect is smaller than rapamycin, but the risk profile is essentially zero. Here's something fascinating. The substances with the strongest effects, rapamycin, acarbose, and canagliflozin, all converge on the same mechanism, and that mechanism mimics the oldest and most reproducible longevity intervention ever discovered, caloric restriction, reducing calorie intake by just 15 to 20% while maintaining adequate protein, vitamins, and minerals extends lifespan in lab animals by 20 to 40% across dozens of independent studies. Not starvation, not crash dieting, a mild, sustained reduction that shifts the body into conservation and repair mode. These drugs are essentially doing the same thing biochemically, just without the hunger. Now, here's what I want you to take away, and I want to be genuinely honest with you. The ITP also tested resveratrol, metformin, curcumin, and a long list of popular antioxidants. Most of them did nothing. That's a sobering result for anyone who spent money on a supplement stack. But, and this is important, that doesn't automatically mean those substances are useless in humans. Mice aren't miniature people. Their metabolism, aging speed, and vulnerabilities are different. The ITP isn't a shopping list for humans. It's a filter for biological plausibility, a way of asking, does this actually touch the fundamental mechanisms of aging, or does it just look good in a press release? The 5 substances that survived this filter deserve serious scientific attention, but none of them come with a human longevity guarantee, not yet. What this field is teaching us, slowly and clearly, is that aging is not a single problem with a single solution. It's a system, and the right intervention depends on who you are, how you age, and what's driving your particular biology. If this video changed how you think about longevity supplements, that was the point. Science doesn't do simple, but it does do honest. Subscribe and hit the bell so you don't miss the next one. Thank you for watching, and here's to your good health. Goodbye.